Hello students, today we are going to start with chapter 5, that is acid, bases and salts of class 7. In this class we are going to start with introduction, then we are going to understand what are acids, what are bases and what are indicators. So in indicators we have two different types of indicators. They are natural indicators and synthetic or man-made indicators. They're also called as artificial indicators. So these are the main concepts what we are going to understand in this class. So let us start with the introduction. So in our daily life, we use a large number of edible substances such as lemon, baking soda, tamarind, common salt and vinegar. Correct? So not only this, we will also use lot many things in our daily life. Correct? Lemon, baking soda, tamarind, common salt, onion, orange. Correct? See, these are some of the substances. Those substances contain acids or bases. See, like soap, baking soda, salt. Right? These are some of the chemicals which will be containing some chemicals. So we need to find what is that chemical which that substance contain. It may be an acid, it may be a base, it may be a salt. Okay, so acid, bases and salts are the three important groups of chemical substances that are used by us in different ways. Yes or no? So these are the three substances. It may be an acid, it may be a base, it may be a salt. These are the important chemical substances that we are going to use in our daily life. So in this diagram shows us the pH value. See here, you can see here acid, neutral and alkaline. Alkaline is nothing but base. So those substances whose pH value is less than 7, those substances whose pH level is less than 7, then they are called as acid. Whose pH level is exactly 7, those substances whose pH level is exactly 7, those are called as water. Okay, so those substances whose pH level is more than 7, it may be 8, 9, 10, 11, 12, more than 7. So those substances are called as base or alkalis. Okay, so this is a brief introduction about this chapter. So we are going to start with acids. So what are acids? Acids are nothing but the substances which are taste sour, or the substances which are sour in taste are called as acids. For example, it may be a curd, it may be orange juice, it may be a vinegar. Correct? It may be a lemon, onion. So these are some of the substances which contain a natural acids, or they are also called as weak acids. We will understand further. So curd, orange juice and vinegar taste sour due to acids present in them. The chemical nature of such substances are acidic. So they are acidic in nature. So the acids in these substances is natural acids. So whatever the acids present in the substances what we are going to eat in our daily life, which we are going to consume, those substances contain a natural acids and are also called as weak acid. So acids have been derived from the Latin word acidus or acer, correct, which means sour. Acidus means sour. Okay, so acids can be of two types, natural acid or artificial acid. So what are natural acids? Natural acids are found in plants and animals and they're also called as weak acids. Natural acids are also called as weak acids. Where these natural acids found? Natural acids are found in our nature or whatever substance what we are going to consume. So those substances contain natural acids. So what are artificial acids? So the acids which are made in labs, which will be prepared by the humans. Correct? So those substances are called as artificial acids and also called as strong acids. They are also called as strong acids. So example, HCl. What is HCl? HCl is a short form of hydrochloric acid. It's a chemical name of hydrochloric acid. And also sulfuric acid, nitric acid, etc. So there are a number of acids which will be prepared in the labs. They are called as artificial acids or strong acids. So this is all about acids. Yes. Next we will going to study about bases. So what are bases? So for example, baking soda, it is not sour in taste, so it is not acidic. So I have told you in acids, the substances which are sour in taste are called acids. So similarly, you can understand bases also. So the substances which are not sour in taste, instead they are bitter in taste. So those substances which are bitter in taste and also soapy to touch. The substances which are bitter in taste and feel soapy on touching, they are called as bases. So these are called as bases. The nature of these substances is basic. So what is the nature of those substances? Those substances nature are basic. They are basic in nature. So they are also called as alkalis. So they are also called as what? Alkalis. Okay, so example of bases are potassium hydroxide, ammonium hydroxide, calcium hydroxide, sodium hydroxide, potassium hydroxide, and magnesium hydroxide. See, these are some of the examples of bases. So how you can identify the bases? So whatever the chemical substances ending with OH or hydroxide, so they are considered as bases. Okay. So main point, what you need to understand in bases. So the bases are bitter in taste, soapy to touch. What about acids? Acids are sour in taste. Okay. Yes. Next we are going to understand what are indicators. So what are indicators? Indicators are nothing but it is a special type of substance are used to check whether the substance are acidic or basic in nature. For example, if your teacher give you a substance and tell you to find whether the substance is acid or base, so you can't taste all the acids and bases. You cannot taste all the substances, correct? As you know, acids are sour in taste, bases are bitter in taste. You cannot taste them, correct? Some acids you can taste, but not all the chemicals, correct? So what you need to have some other special substances which will indicate or which will tells you which is acid and which is base. Okay, so those substances are called as indicators. So the indicators change their color when added to any of the acids or bases. So what does indicator do? They will change their color. These indicators will change their color when they are going to add to a substance. So we will learn what indicator will change to what color, correct? So this we will study in next further slides. Okay, so they can be a natural indicators and also be artificial indicators. In indicators also we have two types, natural indicators and also artificial indicators. So what are natural indicators? So natural indicators are nothing but turmeric. So you know, like Harishina. In Kannada they will tell Harishina. So that is turmeric. China rose. It may be hibiscus. And also litmus, correct? So these are the three natural indicators. So we will discuss about these natural indicators. Before that, we are going to understand what are artificial indicators. So artificial indicators, the indicators which are made in labs. Again, indicators which are made in labs. Okay. So example, phenolphthalein. Need to pronounce it properly. Phenolphthalein. Second one is methyl orange. There are n number of indicators, but important they have given here. Phenolphthalein and methyl orange. And what is the table? Table is given. So what happens when phenolphthalein or methyl orange is added to the acid? What color it will change? And the same solution if added to base, what color it will change? That is the table they have given here. So for example, if I take, okay, here they have given the natural indicator also, one of the natural indicators, litmus also they have given here. We'll understand first. So if litmus, I have told you litmus, right? Litmus is a natural indicator which are made with the help of lichens. Litmus is an indicator which are made with the help of lichens. Okay. So in litmus, we have two types of litmus paper. Correct. Litmus can be a solution and also it can be used as a paper. Here they have used as a paper. In paper we have two types, a blue litmus paper and red litmus paper. Okay. So first they have taken blue litmus. Okay. So they have taken blue litmus and tested with an acid. If that blue litmus changes its color to red, then the solution is acid. Okay. Yes. Now same blue litmus is tested with base. Same blue litmus tested with base. There will be no change. Why? Because always if the given solution is acid, then the blue litmus will turn into red. If the given solution is base, then when we are going to test with blue litmus, there will be no change. Okay. What about in neutral substances? What about in neutral solution? So what is neutral solution first? Neutral solution is nothing but the solution which is neither acid nor base. See, in the first slide I have explained you the pH scale, correct? Whose pH level is exactly 7. Those are called as neutral substances. Those are called as neutral substances. Okay. Next we will study red litmus. So when we take red litmus and test with an acid, there will be no change. I already told you the red litmus. If you want to test acid, you need to use blue litmus. If you want to test base, you need to use red litmus. Okay. So red litmus will be having no change in acidic solution, whereas red litmus will change to blue litmus when you test with base. And in neutral substance, there will be no change. Both red and blue litmus will be having no color change in the neutral solution. Next will be coming for artificial indicators. Here they have given methyl orange and phenolphthalein. So what happens when methyl orange added to acid? When methyl orange added to acid, it will change its color to red. Similarly, methyl orange added to base, it will change its color to yellow. And what happens in neutral solution? When methyl orange is added to neutral solution, it will change into orange. Okay? Yes or no? Yes. Next, phenolphthalein. What happens when phenolphthalein added to acidic solution? The phenolphthalein solution turns the solution into colorless. It will change its color to colorless. Similarly, when phenolphthalein is added to basic solution, then it will change its color to red. Again, when phenolphthalein is added to neutral solution, again it will change its color to colorless. So what you can understand, phenolphthalein is used to test the basic solution. It is better to test the basic solution with phenolphthalein. Why? Because there will be a huge change. When compared to acidic and neutral solution, the basic have different color. Correct? So you may get confused. When the phenolphthalein changes its color to colorless, you can have a confused that it is an acid or neutral substance. So better you should not use phenolphthalein to test acid or neutral substances. Instead, you can use phenolphthalein for basic solution. Okay. Next we have litmus. Litmus is a natural dye. Natural dye. Dye means color. So litmus is extracted from lichens. It has a mauve purple color in distilled water. So when lichens are kept in distilled water, it will change its color to purple. So they will be obtaining a purple color liquid. Nowadays available in paper strips from red litmus paper and blue litmus paper. So you will be having two types of litmus paper, red litmus paper and blue litmus paper. So when litmus is added to acids, it turns red, and when added to bases, it turns blue. So if you want to test the acids, you need to use blue litmus. It will change its color to red. And when you want to test with base, you need to use blue litmus. It will turn in. You need to use red litmus. It will turn into blue. Okay, this is what you need to use when come to litmus. Okay, next. But if substances do not change its color to red or blue, litmus are called neutral solution. If there is no change in color, then the solution will be a neutral solution. Okay. So here they are given diagrams here. The first one is acid, second solution is a base. So first solution they are using blue litmus. The blue litmus is going to change into red litmus because it is an acidic solution. In second solution, you know that it is a base. So you are going to test with red litmus. The red litmus is going to turn into blue litmus. Okay. Next you have turmeric as an indicator. Turmeric, I told you, turmeric means arishina. So this is also one of the indicator. Okay. So mainly turmeric, in turmeric, what you need to understand, turmeric is an indicator which is used to test only the base. There will be no change in acid. Turmeric will be having no change in the acid, whereas turmeric will change its color to red when you test with basic solution. See here, turmeric paper, acidic solution, no change. It will be a yellow color itself. Whereas turmeric paper, when added with basic solution, it will change its color to red. Next, we have China rose. What is China rose? I told you, it is an hibiscus flower. Okay, they'll tell Godal in Hindi. So soaking China rose petals in hot water creates solution that can be used as base indicator. How you need to prepare a base indicator? That is China rose indicator. So soaking China rose petals. China rose petals you need to soak in a hot water. Leave it for some time, then you get a solution that is dark pink color solution. That will be an indicator. So acid turns China rose to red color or pink color. So if you test the China rose indicator with acid, it will change its color to red or dark pink color. When same China rose indicator, when you test with base, then it will be turn its color into yellow or greenish. So here there are difference between acids and bases. Acids are sour in taste, bases are bitter in taste. Acids turn blue litmus paper to red, bases turn no effects on blue litmus paper. I have told you, acids are tested with blue litmus, whereas bases are tested with red litmus. Fourth point, no effect on turmeric paper. Why? Because turmeric indicator is used to test only the base. Next, turns China rose solution to dark pink, turns China rose solution to green. So these are some of the differences between acids and bases. So we will recap what are the definitions what we have studied in this class. The first concept we have studied is acids. Any substances that are sour in taste are called acidic in nature. Example, lemon. Whereas any substances that are bitter in taste and soapy to touch are basic in nature. So they are called as bases. Example, sodium hydroxide. Yes. So today we have learnt about acids and bases and their examples. Then we studied about how to check whether the substance is acidic or basic in nature. That is indicator. With the help of indicator, we have studied how to test the substance is acid or base. And also we have learned many examples of indicators with the help of examples. So the next concept we will be studying in the next class. Thank you, students. Hope you understood. Bye-bye. Hello, students. So in the previous class, we have completed the concepts like acids, bases, and salts. So in acids, bases, and salts, we have studied what are acids, what are bases, and what are indicators. So in this class, we are going to study what is neutralization, what is neutralization reaction, and also how neutralization takes place in our everyday life. Yes. So first concept is neutralization. So what is neutralization? So the reaction between acids and base to produce salt and water is called as neutralization. So what is neutralization? The reaction between or the combination between acids and base. When acid is combined with base to produce salt and water. So this reaction or this concept is called as neutralization. The equation of this reaction is written as acid plus base gives rise to salt plus water. So in neutralization reaction, a new substance is formed called salt. So during the neutralization reaction, a new component is formed or new substance is formed, and the new substance is called as salt. Salt may be an acidic or basic or a neutral in nature. So whatever the salt produced in neutralization reaction, the salt may be an acid or may be a basic or it may be a neutral substance or neutral in nature. So examples of neutralization reaction. So for example, hydrochloric acid, that is HCl, reacts with sodium hydroxide, that is NaOH, give rise to sodium chloride, which is an salt, that is NaCl, plus water. So as the equation, general equation say, hydrochloric acid plus base. So what is acid here? Hydrochloric acid is an acid. Combines with base. What is a base here? Sodium hydroxide is a base. So when acid reacts with base, it gives rise to salt plus water. Here the salt is sodium chloride, NaCl. And also it liberates with water, that is H2O. Understood? So this is one of the neutralization reaction example. So in the process of neutralization, heat is always produced or evolved. The evolved heat rises in temperature of reaction mixture. So whenever the neutralization reaction takes place, here heat is evolved or heat is released. Okay. Neutralization in daily life. So where and all you see neutralization, how neutralization helps. So these are the concepts we are going to understand now. The first one is indigestion. What is indigestion? Whatever the food what we have, it is not digested properly in our stomach. That is indigestion. See, our stomach contains hydrochloric acid. You all know that in nutrition in animals, we have studied this, right? Our stomach contains hydrochloric acid. The stomach, inner wall of the stomach releases hydrochloric acid and the digestive juices to digest the food what we have eaten. Correct? It helps us to digest food, but too much acid in the stomach causes indigestion. So when this too much of acid is released in the stomach or excess of acid is released in the stomach, it will cause us indigestion. To relieve, to get rid of indigestion, we take an antacid. So what is antacid? To kill the acid content, we are taking antacid. So antacid in the form of milk of magnesia. So what is this milk of magnesia? The milk of magnesia contains magnesium hydroxide. As I already told you, magnesium hydroxide is a base. What we have inside our stomach? Hydrochloric acid. It is an acid. What we are going to take? We are going to take magnesium hydroxide. It is a base. And as you already know, acid when combines with bases, it will release salt plus water. So the various salts have been released in our stomach and also the indigestion get rid. How? It will neutralize. It will get neutralized. The acid content in the stomach and the base what we take, it will get neutralized. Okay. So this neutralizes the effect of acid. This is the one concept where you can observe neutralization in our daily life. Second concept is ant sting or ant bite. The sting of an ant contains formic acid. When ant bites you, it releases formic acid to your skin. When ant bites, it releases acid into our skin. This causes itching and irritation. This effect can be neutralized by moist baking soda. This can be neutralized by rubbing a moist baking soda. That is sodium hydrogen carbonate. That is the chemical name of baking soda. So this can be neutralized by calamine solution also, which contains zinc carbonate. So when the formic acid is an acid content, when it is released to our skin, we can remove that or we can neutralize it with help of baking soda, that is sodium hydrogen carbonate, and also with the help of calamine solution, which contains zinc carbonate. Okay. Next concept is soil treatment. So the farmers will know this concept very well. So much use of chemical fertilizers. See, nowadays there utilization of chemical fertilizers more and more. By utilizing or by using chemical fertilizers, the soil also become too acidic. So plants did not grow in much acidic and much basic soil. The plants or the crops what we grow in the land, it will not grow if the sand is or soil is too acidic or too basic. Okay, the crops won't grow in the sand which is either too acidic nor too basic. Okay, it should be neutralized. Then only the crops can grow efficiently. So when the soil is too acidic, it can't be treated by bases. it can be treated by bases like quick lime, that is calcium oxide, and slaked lime, the calcium hydroxide. So when the soil is too acidic, what you can do? You can treat the soil with the quick lime, that is calcium oxide, or slaked lime, that is calcium hydroxide. Okay. So if the soil is too basic, then organic matter is added in order to make it neutralized so that plants can grow. If the soil is basic, too basic, so you can add a organic matter, that is animal waste, organic waste. Now you can treat it with organic matter, then it will release as acid content and will neutralize the base. Okay, so this is what you can do in the soil treatment. And the last concept is factory waste. So you have observed in many rivers, the factory waste has been dumped or released, and the aquatic loss of aquatic life, most of the aquatic life has been lost their life, correct? The waste of factory contains acids. If they are allowed to flow in water bodies, the water body becomes acidic and many aquatic plants and animals may killed, correct? So the factory waste is first neutralized by basic substances. If they are going to release acid into a water bodies, then they need to be mixed with the basic substances so that the chemical substances will get neutralized and there will be no harm to any aquatic body. Okay, so this may not make the water body acidic in nature. So when you neutralize, then there will be no effect to the aquatic life. Okay, so this is the last concept that we are going to know, that is neutralization in our daily life. Okay, so these are the some of the examples they have given where and all we can see neutralization. Okay, so in this class we have studied neutralization, its definition, equation, and few examples. Then we learned about neutralization in our daily life. Hope everyone understood the concept of acids, bases, and salts. Thank you, students. Everyone